Very good. So this follows directly on from 9F. We were talking about confidence intervals for proportion. And you recall that in 9D we were talking about confidence intervals for mean, and then we went on and calculated the sample size and tested claims. We're doing the same thing with confidence intervals for proportions. So firstly we're finding a sample size to justify a certain width, and then we're going to test claims as well. Now, in 9F.1, we calculated the confidence interval, and it was for the number of students that play Fortnite at Tennyson Woods College. So we found P hat was 55 out of 100. So we had a P hat value of 0.55. So that's our observed proportion, right? That's what we've observed based on the data we've collected from 100 students. And when we calculated the 95% confidence interval, this was the confidence interval we had. And we can see that's a width of just below 20%, right? From 0.45 to 0.64, it's just below 20% or 0.2. Now we want to reduce this width. We want a width of 5%. So we want to make the confidence interval narrower. We want to be more confident in our claim and restrict that domain. And so our question is, what's this value of n? How many people do we need to sample? Now similarly, we can, just like with the previous formula, we can rearrange it for W to find the width as well, given a sample size. Nonetheless, let's answer the question. The question is, how many people do we need to sample in order to have a width of 5%? Now, you'll notice here there's a difference between this P hat and P star. There's not really a significant difference. I think the only thing to know is we use P hat when we're given it, and if we're not given it, then we use P equals 0.5. And the reason we use 0.5 is because that's like the worst case scenario. So if we don't know anything about the proportion, then we assume the worst case scenario in order to guarantee a certain level of confidence. Okay, so 0.5 is when this has the most impact on the size of the sample. So we do have a observed value P hat, so that's the one we're going to use anyway. All right, so we're going to have n equals 2 times 1.96 on top of the width. The width is 0.05. We're going to square it, and we multiply it by we've got our P star, and our 1 take P star value. Okay, so we'll process that and evaluate it. Got 1,521. Okay, so that's all we're doing there, processing that for n. And so in order to be more confident, we need to increase our sample size by a fair bit, by a factor of 15. Cool, so that's F.2. That's all I'll go through for now. F.3 we might go through a bit later. We'll see how we're going.